I think we can see the potential and the excitement around what's possible with all of this, but how do we know that the computer is going to be right? How do we know, how can we trust that it's going to be right and not get Hal or Joshua scenarios? So our next speaker is going to actually talk about that. Mia Dand is the president of Lighthouse 3. She's here to shed some light on the concerns around accuracy and ethics and trust around AI. She's an expert in the field of ethics in artificial intelligence. She is the author of 100 Women in AI Ethics, which is an online directory to recruit and recognize talented women in AI. And she's going to educate us on this topic. So please help me welcome Mia Dand.
Here's my fight song. Take back my life song. Prove I'm alright song.
Hi, everyone. Let's see. It's great to be here. I'm Mia Dand, and I'd like to walk you through a journey that I've been on and which led me to be here today. So let me see if I can figure out how this works. Perfect. So I'm here to talk about, can we trust the discoveries and conclusions from AI? So I started in Silicon Valley in the early 2000s. It was a very different world back there. Back then it was eBay. I started with eBay. That was my first corporate job in the Silicon Valley, and eBay was a big kahuna then. Nobody cared what Facebook was doing. Google was just taking off. A lot of these companies were just getting started. There wasn't a lot of talk about AI in those days. I started as a tech blogger. So a lot of my efforts were focused on helping companies identify new technologies, working with these technology companies, just helping them be more efficient and all the business metrics that you can think of. So I got a lot of well-meaning advice during my time in the corporate world, in the technology world. One of it was run fast, break things. It gives you a sense for the ethos of the technology world, right? Ask for permission later. This was the first piece of advice from my manager back in the day. And more recently, about 5 years back, I got this piece of advice, which was chill, right? Take it easy. It's not like we're saving babies. So I've heard it many times, but 5 years back, I found it jarring because my mom had just passed away. And I thought to myself, like, we have the best talent, we have the best brains, and we have all these resources in Silicon Valley. Why aren't we saving babies? So that started my disillusionment with the technology world. I left the technology world, started my own firm, which primarily focuses on the responsible adoption of technology. No more breaking things, right? We want to fix things. A lot of my focus in my work is around governance, it's around compliance, and as Dan mentioned, it's also a lot of ethics. I also work as a vendor-agnostic matchmaker, helping connect companies with the leading technologies, emerging technologies, startups. Also work on AI and emerging, we host our own events, meetup events in the Bay Area as one of the largest AI emerging technology meetup group in San Francisco. Last but not least, we recently launched a huge initiative on the ethics of AI. So the reason I'm excited to be here today is because when Laurie reached out and said, hey, you want to do this talk? And I said, of course I do. These are people who save lives. So that's why I'm here today. So let's talk about, we talked about where I'm from, why I'm here. Let's talk about where we are going over the next 20 minutes. So what is artificial intelligence? I know everybody has a good understanding, but I will, just to level set, we'll talk about like what is it all about, just go into some of the details. Spoiler alert, I won't be talking about Terminators, no killer robots in my talk, that's another talk. So we'll talk about applications of AI. Can it do? What can it do? We'll talk about reality versus hype. Can it actually do that? And just because you can doesn't mean you should. We will, of course, talk about the ethics of AI. And we'll just have some final thoughts on it. So I have a ton of information to go through, so I'll be going really fast, but we will have a few minutes for Q&A at the end. So what is artificial intelligence? Ada Lovelace was the first person who saw the potential of computer programming. She looked at these machines as more than just calculating machines. It was around the same time her contemporary in the 50s who wrote the seminal article on intelligence and machine intelligence, Alan Turing, who posed this question for the first time is, can machines think? That led to the surges in thinking around AI, artificial intelligence. The Turing test is named after him, which is this notion where can machines pass as a human based on a series of questions? And recently, some would say we did. So this is an ongoing debate. There are multiple schools of thoughts on this. There is a school of thought that thinks that machines can only do what we ask them to do, so artificial intelligence can be controlled. There's another school of thought, like the folks at Singularity and other places, who believe that machines can get out of control, hence all the killer robot scenarios, the Terminator scenarios. But watch this space is still an ongoing debate. So let's just get level set. What is machine learning? What are we talking about here? When we talk about AI, we're really talking about a branch of computer science here. We're talking about narrow intelligence, things that are in your computers, in your phones right now. It's very task-based. We're not talking about AGI yet, although some people do talk about it. We are still ways away from that. ASI as well. But we talk about machine learning, which is another subset. The primary use cases in this space tend to be around supervised learning. And again, there's a lot of labeled data that goes into creating these machine learning models. But then there's deep learning, right? That is like the holy grail where machines can go much deeper. They can actually mimic the human brain. But again, it requires a lot more data. And I'll talk about how AI is a lot about AI. It's all about data. How many people have kids here? You know how you teach a child, you give them enough pictures of cats, say this is cat, 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 and ultimately the child gets it. So when you're thinking about machines that are going to mimic human beings, that's what we're talking about. You tell a machine enough times what a thing is, the machine will spit out the answer. But I hope that kind of highlights what the issues are with machine learning. If not, it's coming soon. So how do you train a machine learning model? So again, it's about data, the multiple types of data. It all starts, because a lot of information we have right now, the data that we have right now is not usable. The machine learning models and the potential of machine learning is limited by the amount of usable data. That's why a lot of use cases are limited to where we have good data. So a lot of work goes into just preparing the data. I think Thomas did a great job of showing like how much work it takes to actually put these together, put the data together, and then you prepare it. You do some feature engineering. The way I like to explain it to folks who are not from the AI world, who don't work on machine learning, it's like baking a cake. You have to decide. You bake anything, right? You decide what your ingredients are. You decide what's the recipe you're going to use. And then end of the day, you come up with something that looks like a cake, or I'm not a good baker, so it's usually a mess, but you come up with a decent model, right, a machine learning model. But the thing is, it doesn't stop there. You then have to validate your machine learning model on your test data, not your training data, completely different, because otherwise it's a self-fulfilling prophecy. You have to do it with separate sets of data. But you test it, and then you deploy it, operationalize it, you update it. So this is a dirty little secret that nobody tells you, is that every time you have a change in the inputs into your machine learning model, you have to run the test again. You have to validate it again. And that is a very manual process. And this is literally what it looks like. You walk into this process, you're building your models, you walk into the process of thinking, you have a certain output in mind, but a lot of it is just you're stirring the data, you're stirring it until you get results that actually are similar to what you think. So you have to go in with the end in mind. So let's talk about applications of data and why we're talking so much of applications of AI and why this is so much in the news is because a couple of things had to happen to get us to this stage. One is the exponential increase in computing power. Because look at the phones that we have, right? 5 years back, what could your phone do? Right? We have made so much progress. I think that's the more powerful piece of AI sitting in your pockets right now. Development of AI chips. Google is leading the way in it with the tensor chips, which are they're optimized just for machine learning. Massive amounts of data. Imagine like how much content is being generated every day, data that you are all putting out there in social media, patient data, every touch point that you have with a patient or a customer or user generates more data. So we are awash in data. And then we have these really sophisticated machine learning algorithms, lots of PhDs, a lot of smart people out there building all these new algorithms. And that boom has led to this whole ecosystem of machine learning startups and AI startups. And there's not a single part of the industry that has not been touched, whether it's medical diagnostics, you're talking about mental health, we talk about pathologies, we talk about clinical trials, you name it, it has been touched by AI and it's growing. So one of the things that Thomas touched on was the potential for AI, and there's so many, right? I could go through the entire list, but we're seeing a lot of promise in developing new biomarkers, using AI also to come up with testing thousands of compounds, coming up with new uses for existing drugs, so coming up with new drugs from existing ingredients or off-the-shelf assets that's still on the shelf, which you haven't used. So there's a lot of promise there, but there's also this, it also helps in reducing the risk. It can get you to clinical trials faster, so it can also be used to make your processes more faster and get to market faster. So we are here, there's been a lot of interest in the space. Obviously, the top 10 pharma companies have some sort of initiative. They have tied up with AI companies, they're working with universities, they're working with a lot of different groups to actually further this progress. There's also a lot more promising news coming out of diagnostics, medical diagnostics. Can we do early diagnosis of diseases? And again, a lot of promising news. So at this point, you should be asking yourself, like, okay, I get it, Mia, but we know the promise. How much of that can we actually trust? So what you're actually asking is, can we trust AI? So let's start with the hype. Anyone know this product? It's called Juicero. It was pulled off the market. It is a juicer. It's a very fancy $400 juicer that was introduced. It was pulled off the market about last year. So these are juice packets that you plug into a juicer and, to get fresh juice every morning. Anyone see an issue with this? So somebody figured out, of course, like all these, it doesn't take a rocket scientist to figure out that you could actually take the juice packets and squeeze the juice out. So it was pulled off the market, and this is an example of technology for the sake of technology. When we talk about AI or any technology, we think about the promise. We say, wow, it can do all these things, but sometimes it's just a glorified, like a juicer, right? Everybody should be familiar with the story, again, where hype doesn't meet reality. A lot of scientists already knew about it. It wasn't them, but there was so much media focus, and you have to then start questioning, gosh, if everybody else, all these experts are saying it's the right thing, it really works, then should I be the one questioning it? The answer is yes, you should be questioning it, because a lot of smart people did. Then you think about all the results that are coming out of innovation that's coming out of really well-known elite institutions, organizations that we have come to trust. MIT lab, there was a story done on a product they launched. It's called a food computer. And the notion is that you can actually create tomatoes from Tuscany right in your lab. The problem is, again, the hype doesn't meet reality. There isn't a lot of evidence to show that it actually works, but again, the media has picked it up. And the challenge of the world we live in, a lot of funding is based on the hype. The more hype you have, more media coverage means the more glamorous it is, more sexy it is, the more funding you get. So that literally drives a lot of this media coverage. So to AI, right? A lot of AI models we see out there, there is a lot of promise, but sometimes it's just glorified statistics. That's what it comes down to. So, which is why it requires a closer look. IBM has been at the forefront of a lot of research, a lot of AI in healthcare. They were about the first one with Watson. They were out there, they have great technologies, but the University of Texas, they were running this pilot, they recently pulled it because despite all the promise and all the pilots they ran, after 4 years, millions of dollars spent, they could not move from pilot to scale. So they couldn't come up with a tool that it actually used with patients. So again, you can start with good promise, great pilots, but then if it doesn't scale, and I believe Thomas also alluded to it, as did, I believe Dan did as well, was the point of pilots when you can't actually help the patients. And this is why. Hard problems are just hard to solve. I don't need to be the one to tell you that. They are hard to solve, and the reason they haven't been solved is not because nobody came up with a fancy algorithm before, right? It's because it is hard to solve. There's a data issue, and there's a lot of issues as you're building, going from hype to pilot to scale. There are a lot of challenges along the way. So I'm just taking some of the recent headlines. There's questions on everybody's mind. Can we trust AI? And one of them is, can a self-taught computer make the right diagnosis? So how can we tell? So explainability. So you explain the results. Like, how are the results, how is AI coming up with these results? So University of Washington did a research on, they've developed an algorithm and to sort between images of huskies and wolves. 90% accuracy. So you think it's a good number, right? 90% is good? So if it's able to do that. So then they looked into how it's deciding which one is a husky and which one is a wolf. Turns out it was looking at the snow in the pictures. Yeah. So good news, bad news, right? So machine learning algorithms will use every possible data that's available to them, which humans don't do. Humans have a tendency to not pay attention to some details. This is why we miss out details. We make mistakes because we don't pay attention to everything. The good news is machine learning algorithms can do that. Bad news is they look at everything. So they're looking at snow that you know, I know, we would look at the pictures, say, we're not looking at the snow. But what ended up happening was they created a snow predicting algorithm, not a classifier algorithm. So, algorithms, can an algorithm predict pneumonia? So radiologists obviously are skeptical for many reasons, and they do have a good point. So machine learning algorithm was trained to distinguish between X-rays of between arm, leg, mammograms. What they found out was when they looked deeper into how it was arriving at that conclusion, what is what, how it was classifying, they found that it was looking at the position of the breast on an X-ray, because the breast is always attached to a chest, and which means it's always around the edges of the X-ray. So it gave a high probability, a higher score to an X-ray based on the position. See, you can have an accurate conclusion, you can have an accurate diagnosis, but for the wrong reasons. Here's another example for TB. So algorithm to detect TB. In this case, the algorithm was looking at the scanner that was used. It gave a higher score to portable X-ray machines. Think about portable X-ray machines. When you have a pneumonia patient, somebody who is a high-risk patient, that person is more likely to be in a hospital. Hence, a portable X-ray machine, which means the higher score, higher probability of it getting a right result. See, again, right answer, not for the right reasons. So when healthcare starts making diagnoses, how accurate are they? So we talked about how is it arriving at the conclusions. Now let's talk about accuracy. So the algorithm for TB diagnosis is about, this is from Stanford research, by the way, in case you're wondering where these numbers are coming from. So Stanford research has found that 75% of the time, the algorithm is going to get the diagnosis right. So how many people think 75% is a good number? Show of hands? No? Not good enough? So this is what they say. But the doctors in South Africa are correct 62% of the time. It all depends on what your threshold, it all depends on what you're comparing it with, because what you're sold on is always this notion of it will be better than a human, but is that the bar we should be shooting for? Right. So IBM was criticized again. I'm not beating up on IBM. They're good people, they're trying their best, but it's giving a diagnosis, it referred a medicine for a patient with lung cancer. But what it didn't take into account that the patient also had bleeding, internal severe bleeding, but the drug that it suggested had a side effect, which was also causes bleeding. So again, there is an issue with it can sometimes provide you with a diagnosis or a result which addresses the issue, but it may not consider the other factors because it hasn't been given that information. So garbage in, garbage out. So something that FDA is grappling with, a lot of regulatory organizations or agencies are grappling with is how do you account for unknown unknowns, right? Once the algorithm is out in the market, so it changes, evolves constantly. How do you stay on top of it? How do you validate it? How do you use existing standards? Because there are standards for statistical models today that are being used by FDA, but algorithms are different because a lot of them are black boxes, a lot of them evolve, they change. So FDA is trying to come up with a regulatory framework, and they had invited discussions on this, and it's an ongoing process. It is not done yet because they're trying to figure out once a device with machine learning devices out there in the marketplace, how do you continuously monitor it so that any changes happen? Because we're right now in the era of unknown unknowns. So this is something that's actively under investigation. So lack of transparency. Now this is a big part. The biggest failing in AI right now is this lack of transparency. And why this matters is we are sold in this notion of AI being all-powerful, it's all about machines, but a lot of the data labeling that I talked about is being done by humans. It's faster, cheaper, and a lot of AI companies are using this. So transparency matters, not just for ethical reasons, but real reason. If you're being sold on a technology that can do X, Y, Z, and then you find out a human is doing it, and there have been lots of instances where that has happened. Sold on technology, but a human is doing the job. So we talk about Amazon, and all the big tech giants are making strides in this space. Alexa, so Amazon's Echo has 6 of Alexa's skills are now HIPAA, certified HIPAA compliant, which is great, right? We want them to follow the norms and regulation. Why should they be immune to it? But here's the problem. On one hand, you have the HIPAA compliance, but on the other hand, you also have workers who are listening into your conversations. Because the way machine learning algorithms get better is because there's some human in the loop who's actually testing it, who's checking it, the accuracy of it. Which is great, it gets better, but what about the patients who don't know? They've been actually communicating with AI, but there's actually a human being who's listening in. Privacy has been a big issue again. You can have the best technology out there, you can have the right diagnosis, but it doesn't matter unless your patient consent. And Google DeepMind got into big trouble with NHS over in the UK precisely because of this reason. So Cynthia Rudin, she's an associate professor over at Duke University, and she has been the most vocal voice, and as she should be, against black box algorithms. They work in certain organizations, certain industries, but not for life-saving decisions. You need to know what's in there. How are you making these decisions? You need to be able to explain, not just explain, you need to be able to stop these black box algorithms because there's too much at stake. So which brings me to the ethics of AI. We all know the scene from Jurassic Park. Okay, I said no Terminated robots, but I didn't say we wouldn't have Jurassic Park. But just because you can doesn't always mean you should. Here's where the ethics comes in. So should AI be able to tell when somebody's going to die? And right now, there's work underway where Eric Topol calls them dying algorithms. Could we do it? Maybe, sure. There are companies working on it right now. There's smart people in the industry working on it right now. The question is, should we? Do we want to know? Do we want to predict it? Imagine the consequences. Imagine what this means for healthcare. Think of the ethics of it. Would you deny care to a person because you know that person is going to be dying because the algorithm said they're going to be dying in a few days? Would you withhold care? And that is a real concern because insurance industries can actually use this information to deny healthcare. Clinical trials, right? So there are different types of ethics, but here's a bigger one. We talk about accuracy, we talk about whether or not the diagnosis that AI is putting out is right, but when your clinical trials are based on, say, all white men, which is a big issue right now, it's not going to work like for me or somebody who looks like me or the women in the room. So there's something or the minorities, and there's a real issue that we need to address because AI is based on a lot of data. It's the data that we are supplying to them, and we need to address that before AI is wrong or it's wrong for all the wrong reasons. So I was at Oxford last week, and I had the pleasure of listening to Sir Nigel Shadbolt talk about this new grant they've received from the US millionaire Schwarzman. Mr. Schwarzman has donated a large fund to set up ethics center, which will sit within the new Humanities Center. And I like the notion that they're exploring this new notion of having AI ethics reflect medical ethics. Because medical ethics already has this nice, robust body of thought. It has been around for a while, it's been tested, so why not use medical ethics as the basis for it? It's still under exploration, but I really think it's a very solid idea, because you already have human consent, you have patient consent, you have many more safeguards in place to ensure that whatever diagnosis we are coming up with, we are actually accurate and they're ethical. At a separate conference at Oxford, we launched the 6-dimensional AI ethics model, which highlights there are different dimensions of ethics, and they're all interconnected. These are not mutually exclusive. When we talked about AI diagnosis, the question comes up, and it should come up more often, what happens to the radiologists who are going to lose their jobs to AI? That's a serious concern. And how about when you have fairness accountability, we talk about whether or not it is going to be accurate for one set of people. What about, will it be accurate for another group of people, the minority? So is it fair? Digital and physical safety, we talked about, can AI kill us? I think the bigger issue is it ethical? Is it making the right decision on our behalf? We talk about commercial system safety. We talked about Alexa giving the wrong diagnosis is always an issue. Privacy and data rights, do you have consent? And last but not the least, human rules and rights. When AI starts making decisions on basis of overrides radiologists, pathologists, and even maybe physicians and doctors, what about the human rights? Where does the patient, how do you make sure the patient doesn't get lost in the mix? So we also launched this directly last week, which is an open online directory where you can actually find amazing women experts who are working specifically on the area of AI ethics. They're deep subject matter experts who are on machine learning, artificial intelligence, and they look at it from all dimensions. So a great resource for those who are looking to hire in this space. It is going live this week. So. Comes down to, okay, so here's why I am here today, is talk about can we or can we not trust AI? What it really comes down to is, can we trust the humans? Because it's not AI who's selling us all these big promises, right? It's not AI who's telling you the diagnosis is right. It's some human being who's looking at it and saying, yes, this diagnosis is right. No, that's wrong. You should override the human. So it's all about the human. So when we do our vetting exercise, when I said that we do help companies match with the right technologies, what we look at is the humans. The people. Who are the people working on this? And I like something, again, Thomas, again, building a lot on what Thomas said, is it's this notion of multidisciplinary teams. You need domain experts on the team. You need people from different groups. So we always look at who are the people building it. Do they have the experts? We do not want to only work with a team of technologists, because that's it's bound for failure for all the reasons I mentioned. But we also look at who's investing in it. Like, what's their agenda? Why are they investing in this? Because intent matters. It matters why you're building the technology, who's impacted by it. We also look at the technology itself. Does it actually work? We kick the tires, we look underneath it. We look at, is it accurate? It's not just, does it work in all circumstances? What circumstances? Is it fair? We look at whether it's interpretable, is it transparent? All the things we talked about. But last is the proof. It's all about the proof is in the pudding. You test it and you test it again. And then you decide whether you can scale it. Because you don't want all these untested models out there which are going to cause havoc, and you scale something that doesn't work. In conclusion, technology is fallible, but so are human beings. More testing is a good thing. Test, 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 unless you're satisfied it actually works. But being skeptical is also a good thing. If it sounds too good to be true, it usually is. AI derives its ethics from humans, the humans in this room, right? We decide what goes in, what are those boundaries that we should not cross, or what should we take into account, what should we care about? But in the end, that's what's going to save us. It's not the accuracy of the technology, it's the ethics of the technology, the ethics of the humans. And that's it. That's pretty much it. Thank you. It looks like about 1 minute for questions. Please, go ahead. Do you want to come to the mic, or you can just shout it out? Either's fine. Go for it.
Okay, sure.
I can hear you.
So, good morning.
Morning.
You alluded a couple times to the painstaking process of revalidation when changes are made.
Yeah.
So, I was curious, are you aware of trustworthy ways now or in the future that the training and tuning paradigm could be applied to the validation process itself? Did this give us what we want? For that matter, do you think it should be? Or is it always going to be humans?
There actually are human beings, right? We are limited only by ingenuity. I would say yes, there are ways that you can actually have tests, checks and balances put in place. And yes, it is possible, and there are frameworks that are built that you can check, and you can actually train a machine to do that. But we are far from that place now, because right now we don't even know what we are looking for. So as that evolves, we would have to, the first phase is, can a human being do it, and do it in a way that works? And then you transfer the skill sets to a machine to do it right. At some point, I'm sure we'll get to the point where machines can be training itself, because we already have algorithms writing algorithms. We already have that happening. So it's only a matter of time before we can have algorithms checking their own work. We're not there yet, but I'm an optimist. I'm sure we'll get there someday.
A question.
Yes.
So can we program ethics, number one? And number two, should artists, musicians, and humanists be in the room as we are in the technology room designing?
I love that question. Because we are actually setting up a technology event for arts and AI as I speak. So I'll start with the second question, which is yes. We can't have technologies building technologies only because that's what leads to all sorts of chaos and the issues that we see today. We do need a cross-dimension, we need a multi-dimensional team. If the ultimate goal is to use AI for the benefit of humanity, to make humanity better, then yes, of course, we need to include more artists, we need to include more creative ties, because that's the full potential of human. It's more than just making money, right? It is about saving lives. It is about having a better future. And you said ethics. You said whether or not the question was, I'm sorry, I was facing on the first question. There are frameworks out there for ethics. There are a lot of, like the list of women I shared, that's what they work on. There are lists, there are checklists, there are frameworks, there are guidelines, how we can do this better. But again, it's all about the humans. It starts with your intent. It has to be the right intent. If you start with, I want to save people, as many people as we can, then you take the trade-offs into account. It may slow down the process a little. It may slow you down. It may not be as lucrative because you're thinking through every step. But end of the day, ethics is what we decide as a society. It's not easy, because not everybody decides on the same set of ethics, which makes it challenging. But ultimately, it's up to us to decide what's the right way to move forward. So I hope I answered your question. And do we have time for another one? Are we good? Any more? Okay. Thank you all so much.